ጤና ይስጥልኝ እንደምናላችሁ መምህር ምርከና ደጀኔ ይባላልው። አሁን ለማቅረብ የፈለኩት የኬሚስትሪ በሃይ ስኩል በተለይ ደግሞ 11 12 የሚማሩትን ቪዲዮ ቀርጬ ላስተምራችሁ ፈልጌ ነው። ይሄንን ሳደርግላችሁ በኬሚስትሪ ያለባችሁን ችግሮችን ቀርፈን ጥሩ ውጤት አምጥታችሁ ራሳችሁን ለሀገር አቀፍ ፈተና እንድታዘጋጁ ነው። ስለዚህ በደንብ ከተከታተላችሁኝ ከመጀመሪያ ጀምሬ 11ኛን 12ኛን አስተምራችኋለሁ። ግን ለጊዜው በትንሽ ቪዲዮ ለመጀመሪያ ያክል ፌዝ ኢኩሊብሪየም ከምለው ጀምራለሁ።
The phase equilibrium is due to the phase change between the substances. First, let's define what a phase means. Phase is not physical state. Phase is the number of boundary within a mixture of the substances. Boundary between substances in the mixture.
Play Store solar code for free production.
Search for phase. For example, if you have oil and water in a mixture, let's say you have
እስከሚያበቃ ድረስ አንዳንድ ነገሮች ይነግራችሁ። በአፕሊኬሽን ውስጥ ደስ የሚለው ኮምፒቲሽን አለ ማለት የሆነ ነገር በኮምፒቲሽን ሲሆን የበለጠ ሰዎች ሞቲቬት ሆነው ይሰራሉና ሌሎች ሰዎች ኢትዮጵያ ውስጥ ካሉ በየትኛውም የዓለም ዳርቻ ካሉ ሰዎች ጋር ኮምፒት የምታደርጉበት ፓርቶች እና አፕሊኬሽን በጣም ኩል የሆነ አለው። ጀስት ሎጊን ምናምን የምታደርጉ ባጭሩ አሳያችኋለሁ። እንግባ።
These are immiscible liquids. Now, in this case, we have two phases. Oil is floating on water. Here we have the water. Here we have the oil part. Therefore, we have two parties within this mixture. Therefore, we have two phases. They have two phases. Then we have two phases in this mixture. And we have also, for example, if you take water and alcohol, let's say ethanol, these are miscible liquids. They are called miscible liquids. That means they form homogeneous mixture. That is a solution. This is also called solution. We call it solution. Now in this case, we have one phase. There is one phase in this mixture. Therefore, we have one phase. This is one phase, and this one is the two phases. This is how to count a phase. For example, the other one is if you take air. The air has many components. Air. Within the air, we have nitrogen, oxygen, and others. Now, this one is also one phase. One phase, we can say here is one phase. If you take another example, let's say a solid materials. Let's say if you have a solid materials like graphite, diamond, and also others. Let's say soot, cork. Here, we have four components, four phases. We have four phases in this case. Now this is what we call about the phase. Component is the substance within the mixture. The number of substance we have within the mixture is known as a component. The number of distinct substances we have we have the mixture. And the mixture is known as component. For example, here let's say again we take water and oil. Water and oil. Here the phase is 1, the component is 2. This is component 2, phase 1. If we take another substance solution, a solution again, air is a solution, homogeneous, it's a one phase. Now here we have components. The components are oxygen, nitrogen, carbon dioxide, etc. are components. This is what the other important concept for this one is the degree of freedom. Degree of freedom. The degree of freedom is the number of variables required to define the given system. The number of variables. For example, to take about the pure water. If you have this is the pure water, let's say this is pure water. Now, to tell its physical state, we need two degree of freedom, two variables. We need two variables to describe about water. Now, these are temperature and pressure. Temperature and pressure are the two variables that we need to describe about the water. To say water is a liquid, we have to specify temperature and the pressure. To say the water is ice or solid, we have to specify the temperature and the pressure, the range. And to take the water is in the form of vapor form, we have to take the temperature and the pressure for the water. Therefore, for any pure substance to describe, we need two variables. That's what we call degree of freedom. For example, at 1 atm and temperature from 0 degrees Celsius to 100 degrees Celsius, the water is in the form of liquid. Water is in the form of liquid. Now we have to know both temperature and pressure to say the water is liquid. And at 1 atm, again 1 atm, the temperature is less than or equal to 0 degrees Celsius. It is a solid. Water is in the form of solid, that is ice. If the temperature at 1 atm, the temperature is greater than or equal to 100 degrees Celsius, the water exists in the form of vapor. Water is in the form of vapor or gas. Now this is the degree of freedom. Now for a given system, we have a phase rule. That can tell us the degree of freedom. Degree of freedom, F is equal to component minus phase plus 2. This is how to calculate the degree of freedom. Now for example, let's say we have a pure water. Let's say this is pure water, pure liquid water. And let's say here we have water vapor, and liquid water. phase is when we have the three phases coexist, the three water forms. Let's say ice, vapor form of water, and the liquid state. Now we have three cases. In this case, the component is 1, the phase is 1, the degree of freedom is equal to 1 minus 1 plus 2. That is 2. The degree of freedom is 2 means we need two variables. It is known as bivariant. Bivariant means we have to have both temperature and the pressure at the same time to talk about this pure water. Here, the component is 1, the phase is 2, the degree of freedom is equal to 1 minus 2 plus 2, that is 1. That is monovariant. Monovariant. That means we need to know either temperature or pressure to talk about this equilibrium. The water vapor and the liquid form are at equilibrium. Here the component is 1, again the phase is 3, the degree of freedom is equal to 0. That means invariant, or it is triple point. That means when the three phases coexist. We have both ice, vapor, and liquid at a single point. We have no any other option for the triple point. The triple point for a substance is a single point where the three physical states coexist. We call it the triple point. Now this question is given to you. It says the degree of freedom for the reaction. Now in this case we have this substance, a single substance decomposed into two substances. Here you can say we have three substances. It is true that we have three substances, but in this case the number of components is 1 because it makes equilibrium. This simple substance decomposed into two substances. Therefore, the component is always 1 unless we have excess. Now the component is 1, the phase is 2. Now the degree of freedom is equal to component minus phase plus 2. Now this is component is 1, the phase is 2 plus 2. Now it is the degree of freedom is 1. That means monovariant. And the next one is another question. Substance exists in the solid state when we are saying at low temperature and high pressure. Low temperature and high pressure means the molecules are very close to each other and solidified. Now therefore the answer is low temperature and at high pressure. True false triple point of the substance is a monovariant system. It says false because the triple point where the degree of freedom is 0. Degree of freedom means invariant. Invariant means no variables required. It's just a single point. That is a triple point. Triple point of a substance is invariant, not monovariant. እንግዲህ እንዳያችሁ ዛሬ የመጀመሪያ ቪዲዮ ስለምለቅ ነው። በጣም በተከታታይ ቪዲዮዎችን ስለምለቅ ቪዲዮዋችንን ሰብስክራይብ በማድረግ ብዙ ማግኘት ትችላላችሁ። ይህንን ሰብስክራይብ ማድረግ እንዳትረሱ።